In previous lecture, we have seen how to calculate the p-value by using simply probability definitions. Just in previous lecture, if you remember, we have learned already that we will how to calculate the p-value by simply using the probability definition. We have seen this thing. Now, in this lecture, in this video, we will learn how to calculate this p-value by simply using the resampling and permutation test technique. Now let's try. Now let's try to understand this thing through an example. First, let's take the examples that we have taken. If you remember, we have two class of students. This is the class 1 and this one is for the class 2, and we have measured the height of the classes for 50 students. So okay, we have measured the height for such 50 students for each class, student 1, student 2, student 3, like that. Similarly for class 2 also we have done this job, 50 students. Okay, suppose let's take it's any value, it's maybe any value. Okay, I'm not interested now the value is height. Now after collecting this observation, means this is the observations, these are the simple observations, and the 50 that's called here is the sample size for the age classes. Okay, the sample size of the age classes. Now in these sections that we have to do, so the job that we have to do here, first here that we have collected two classes, that the examples already we have taken in previous lecture, previous video. So this is the class 1, that randomly for this, on this class we have randomly selected 50 student and we will measure age height. Similarly for class 2 we will select randomly 50 students and we will measure their height. Okay, that's the job already we have, and that's the job first we have to do, and already we have taken this example in previous column. That the main thing start from here. So the first that we have calculated its mean. Here suppose let's take its mean is mu1 and its mean it's mu2. Now after calculating this mean, now we have to find its differences. Suppose let's take its differences is delta. Its differences is delta. Delta is equals to mu1 minus mu. It does not matter if you use mu2 minus mu1 or mu1 minus mu. Both the same kind of thing. So that depends on your requirement. Requirement means that depends on anyone you can choose. So don't be worried about that. Means totally we have to take the differences. Okay. So if this lambda value, because let's take it's I'm taking here norm value, mod value, means I'm avoiding the sign here. Okay, if you take on the means, okay, just first don't just patient with me, just bear with me, then I at the end of this video I will explain. So if it's actually why it's actually does not matter the sign. Okay, let's be bear with me. Now after calculating the mean difference of the mean, next thing that we have to do next at the after calculating this mean, and then we have to mix these two samples, mixed up these two samples. Okay, suppose let's take this is the big sample, this is the big sample. Here we will mix up these two samples. Here we will mix up these two samples. Okay, and after mixing up, so here we have 50 points, here we have 50 points. Now how much points we have here? Here we have now 100 points. So now here we have 100 points, number of points on that set. Now after mixing up, we have jumbled this. Okay, I have jumbled this set. We will jumble this set. Okay, so now this is another samples that we have made from the previous two samples. Okay, so now after jumbling this, we will create the random sample on the big sample. Suppose let's take this is the sample of class 1, this is the sample of class 2, this is the main sample that we created here, capital. Okay, that's now after sampling this is we will create from here our our artificial samples. First we will create, suppose let's take, we will randomly selected one sample from here, capital S set. Suppose let's take, we will randomly select 50 samples and we call it X, 1 2 up to 50. We will randomly select it. First this is the sample 1, and we have randomly selected 50 samples from here, and the rest 50 samples, rest 50 means first we randomly choose 50 points from here and we will put it on X, and the rest 50 points we put it on Y. That is 1 2 50 up to 50. Okay, now after calculating this is the sample 1, this is the, we will create this sample. This is the random sample 1, randomly select, random, this is the random sample that we have created from here, and we call this sample S1, small h1. This one is the small h1. Okay, and this small h1 is the language called the artificial sample that will build from the sample is capital. These things are artificial. Artificial sample that is created from S. Okay. Now the same things also, the same job also, we will repeat the same job again. We will create random sample S2 and randomly selected 50 points, and we will put it on the set X, repeatedly doing this same thing. 50 points, and the rest of the 50 points we put it on the set Y. Rest of the 50. Okay. Similarly, we will repeatedly doing this job. Okay, suppose let's take, we will create such kind of 10k samples, 10,000 samples we will create. We will create such kind of 10,000 artificial samples, and first we will select randomly selected 50 points. First we will randomly selected 50 points, and after the rest of the point, first we will randomly selected the 50 points and it will put it on the set X. The rest of the point we will put it on set Y. Okay, just doing this job, just the same job we will doing here at 10,000 times to create 10,000 such artificial sample. After creating this, we will calculate it as mean. So suppose let's take it's calculated as mean. Suppose let's take its mean is small x1 bar. Mean means it's the mean of these things. Its mean is, suppose let's take y1. Okay, this is the mean of x, that is created mean of that is mean of x mean of x from the artificial sample S1. This is the artificial sample S1. This sample the first mean. First we have calculated its mean. Suppose let's take its mean is x1 bar. Its mean is y1 bar. Similarly for here, for the artificial sample say x is 2. Suppose let's take we got it mean is x2 bar. Its mean is xy2 bar. Similarly for here also 10k bar, x10k bar, y10k bar. Okay, now we calculated age mean, and after calculating we will find its difference. If we taken to find the lambda, if you taken here mu1 minus mu2, then we will use here x1 minus x2. If you will use here mu2 minus mu1, then we will use here y1 minus x1. Okay, the order are also maintained. If you calculate mu1 minus mu2, mu1 means what? Mu1 means the mean of the class students, mean of the class 1 students of the observed value. Okay, means observed value that we have collected, it observed value that we have collected from class 1, that's mean. And the x1 is the mean of the set x that is built from the S, means it's the sample that we have make to jumble the observed value from the class 1 and class 2. Okay, I think you got the idea. Okay, the same techniques also applicable here. If we use mu1 minus mu2, here we will use x1 bar minus y1 bar. If you use mu2 minus mu1, here we will use y2 bar minus y1 bar minus x1 bar. Same matlab means the same order also maintained. Same order same order also maintain for artificial sample, for means for each small a size. Okay, so here we got x1 minus y1. Suppose let's take here we will consider this thing. Suppose let's take we will consider this mu1 minus mu1 minus mu2. So then here the mean, suppose let's take the difference of this is delta 1, small delta 1. In small delta 1 will be now x1 bar minus y1 bar. Similarly for this set S2, we will calculate it. It's delta 2. This delta 2 will be x2 bar minus y2 bar. Similarly, we calculated the small delta 10k. This value will be 10k bar minus y10k bar. Okay, that's the next thing that we have to do. After calculating this, after finding this, means we will get such kind of 10k delta case value, means after finding this we will get x delta 1, delta 2, delta 3, such kind of delta 10k values. Okay, so after calculating these 10k values, 10,000 values, we will sorting this thing from small to larger. We will sorting this thing from smallest to large, small to larger, or you can call it in increasing order. In increasing. Suppose let's take after sorting in increasing order, we will get this guy, this value. Lambda 1 dash, lambda 2 dash means lambda 1 is the most smallest one among all these 10k values. Lambda this delta 2 dash means delta 1 dash is the smallest one among all these 10k values. Delta 2 dash is the second smallest among all these 10k values. Similarly, the delta dash 10k is the largest one among all these 10k values. Okay, I think you got the idea. After sorting this, now after sorting this, that the thing that we have to do after sorting this, we have this a value, we have this capital delta value. This capital delta means what? This capital delta means the simple difference of the mu1 minus mu2. And what is mu1? Mu1 is the sample mean of the observed value of the class 1 student, and mu2 is the simple mean of the observed value of the class 2 student. We have already calculated the capital this delta value. Okay, now we'll find where this capital will be replaced. Means what is the order here? Here it is the ordering. This lambda 1 dash means small delta 1 dash, small delta 2 dash is the ordered value, because we have sort this thing. Now we will find where these things will be replaced. Suppose let's take it's replaced here. Suppose let's take its order will be like here. Then after we ordering this thing, then we will try to find this value. What amount of value are larger than this value? Means how much points are lie on this region, on the right side of the capital. How much points are lie? Suppose let's take the x percentage points. X percentage points are lie on the right side of the capital. Okay, so then we can conclude that here. Then we can conclude that the p-value will be x percentage. Okay, the p-value will be x percent. Similarly, suppose let's take this is 5. Suppose let's take this is the 5. Suppose 5% are point among all the 10k points, only 5% are points are greater than this capital delta. Then we can conclude that our p-value will be 5%, or p-value will be 0.05. Okay, I think you got the idea. I think you understand. I think you got some idea how these things are actually calculated. And the same things also, if this p-value is greater than 5%, then we will accept the null hypothesis. Otherwise, we will reject the null hypothesis. Now the questions that occur into our mind, sir, what is our null hypothesis here? We have not assumed something that in previous lecture we have taken. So this is the very interesting question, but the answer is hidden on this experiment. Now let's see this thing, how these things are hidden on this experiment. So first, what we are doing here? First, that we have taken the class 1 student, we have taken class 1 and class 2 differently, and we have taken we have considered the randomly selected 50 students from each class. Okay, and we will calculate it, the difference of the mean, that is capital delta here. Means this capital delta are the difference of the mean, the class 1 observed value and the class 2 observed value. Now after that we will jumble this thing, mixed up these two observations. Okay, we will jumble up. This means what? If we jumbled up, this means what? This means we will consider this set is as a same means as a single class, means if you jump at this means here we will consider S as a single class, as a single class, not two different class. This means what? This means we assume that in the class 1 and class 2 there have no differences. Means here we assume that there have no difference. There have no difference on class 1 and class 2. There have no difference. That's thing we have assumed here. And this is the sample our null hypothesis. These things are sample the null hypothesis. Null hypothesis is not. That's the things are actually internally hidden. That's thing we have to understand these things. Because all we have assumed these things, they are on the two different class, they have no differences. And on the basis of the different, no, if there have no differences, now from the single class S, we will now sample. We will now make this, we will now make the sample, and the sample are called the artificial sample. Means here S1, S2, S gap. And after sample, the same process also we are doing here. We'll calculate its means and find its differences for the age artificial sample, and we will find that. And after calculating the differences of the mean of the artificial sample, we will find that our original mean or the original difference of the original means, or difference of the original means lie on this thing. Means this much part amount of the data larger than this, larger than this. Okay, if these things are, if this x value are larger, if x value means, suppose let's take it's 50%, it's greater than 5%. If this value are larger, that means what? That means our assumptions is correct, that we assume here there have no any differences. That means there have no any differences, and then we can conclude that our that there have no differences on the on the class 1 and class 2. If this x value are less than 5%, if this x value are less than 5%, then our hypothesis is wrong. Means if these x value are less than 5%, this our hypothesis is wrong. Means there have some differences on class 1 and class 2. That's the thing. That's the internal thing, that the hidden here, that we have to understand. So if this x value, if now that we can conclude here, if this x percentage is greater than 5%, then we accept the null hypothesis. If x percentage is less than percentage, then we reject the null hypothesis is not, or accept the alternative hypothesis. It's the opposite of this. I think you got the idea from here. Okay. How the hypothesis, null hypothesis, are actually hidden on that. I think you got it. Now the thing that we have to in pre-computer day. Suppose now we have a huge computational power. From the example set, from the big set is, we can easily make some kind of artificial sample. Easily we can make this thing, because we can easily generate the random number, and on the basis of the random number we can easily store. We have sufficient amount of computation. That's not a problem in nowadays. But in previous days, where the computers, it means in I am talking about in pre-computer days, means in pre-computer days, how these things are now. Let's try. Let's see. In pre-computer days, how these things are. So in such cases, the mathematicians, the scientists, data science are discovered that the delta that we have computed from the artificial sample, that's delta are that's delta that we have calculated here, the delta is are follows the normal distribution, follows the normal distribution that is discovered by the mathematicians or science, by mathematicians that have they have discovered these things by using some calculations, by some experiment. They somehow they will discover these things, that the deltas that we have calculated from the artificial samples that are follows the normal distribution. Suppose let's take this distribution in normal 0 1 distribution. Suppose let's take the delta is r, the normal 0 1. If suppose let's take, if this follows the normal 0 1 distributions, because we already know the normal 0 1 distributions curve are look like this type, curve, and here it is the simple mean value 0, and here somewhere here it is 1, somewhere here it is 2, 3. Suppose let's take this one, this type. Suppose let's take this type of value. So now how we'll calculate it from here, the p value? Now the p value that we have already known that on the, because it is the Gaussian distributions, and we will and 0 1 distribution, we will know that on the first standard deviation. So here one is here is a sigma is what? Here sigma is equals to 1 and mu is equals to 0, and we know that on the first standard deviations, on the range of the first standard deviation, we have 68 percentage of the point. Let's take each point here somewhere here. On that range, we already known that it is 68%, and on the range of the two standard deviations, means on that range, on on this range, we have 95% of the point, 95% point means what? Means on the whole range we have 95% point, on this range we have 68% point. Means how much point in this side we have? How much point in this side we have? Now this side will be, it will be, must be, rest of the point is 5%. In this side we have 2.5%, and as well as this side we have 2.5. This is 2.5, and in the range of the 3 sigma distribution, 3 sigma, in this range of 3 sigma distribution, we have 99% approx. We already seen these things, 68, 95, 99, already we have seen. So if these things happen, suppose let's take our delta value lying on here, because we already know the lambda delta value. Suppose let's take our delta is lying on here. Suppose let's take, here is our delta, here somewhere here delta is 2. Okay, if somewhere here delta, then we can here decide that if suppose let's take delta is 2, delta is here. Suppose let's take let suppose let if delta is 2, then how much points are greater than this? Means the probability of uh, means this sigma, these small deltas, this is the sample, these small deltas are greater than equals to capital delta. Means probability of small delta that's greater than is equals to 2. Means what? How much? What will be the probability? Because we know this probability is 2.5%. Our points are the greater than these regions. Means this value will be simple 0.025, or this will be 2.5%. Similarly, if the delta value is like on here, somewhere here, then we can easily find this value, how much value will be. So based on this calculations on the pre-computer days, the engineers are calculated at p-value like that, in this by simply using this technique. I think you got the idea how in sampling, resampling or permutation test are useful to calculate the p-value, and how these things are applicable on pre-computer days. The scientists, how these things are applied on to find the p-value. Okay, just I am repeating again to clarify the concept. First, actually in our experiment we have two different quantities that we have to compare these things. Suppose let's take we have two classes. On the two classes we will conclude that the mean height of the students of these two classes are equal or not. Okay, and first we have to calculate its mean difference of the mean of the two classes. If we first we will calculate the difference of the mean of the two classes. Now after that we have to mix up these two observations of the two different, and we make a bigger sampled classes, that's called here S. After making this S, we have collected the we will randomly selected 50 students. We randomly selected some students from these classes, and we calculated its mean. Means we will randomly build some artificial samples from this capital S, from this big sample S. And such kind, and after building this we will calculate the difference of the S. Means the same jobs also applicable on the random sample that we will apply on the big sample. Okay, the same things also apply on the age artificial sample. And after that we will sorting this difference value, and on the basis of the sorting value we will find in where our lie on the mean value. This is the difference of the mean value, this is the difference of the sample mean value, and the small delta sample the difference of the artificial mean. This is the sample from the artificial sample, mean difference of the from the artificial sample. And we will check, and we will calculate it how much points are greater than on this mean, how much points are greater than on our main difference mean. Okay, if we find that it is greater than 5%, then we will accept our null hypothesis, otherwise we will reject this thing, otherwise we will reject this. Okay, that's things we will calculate by using the computer programming technique. Now in pre-computer days, the scientists that are assumed that are actually discovered, actually not assume, actually they have discovered that the small deltas are follows the normal distribution, and on the basis of these distributions, and they will find how much deltas are greater than, actually how much small deltas are greater than capital delta, what is the probability. And on the basis of this probability, this probability value actually called the p value, and on the basis of this p value they will take the decisions. If this value is greater than 5%, then they accept the null hypothesis, otherwise they will reject it. I think you got the idea. If the main thing first the main thing is that clarify your concept, what is actual p value and how these things are actually calculatable. So I think from the previous lecture you got some idea, and on that lecture it will be more clear. I request you, if you have any problem, please recap this, please revisit this video. Okay, and pause this video and try to visualize these things in yourselves. Just compare this p value, how this p value are actually usable on the real world. Just compare these things in your surroundings. Suppose in your project work or in something that you are doing the job. Okay, just compare these things on your own surrounding, on your own environment. Then I think it will be more clear. Okay, just try to compare and just to try to analyze these things in yourself. Okay, I think then. So in the next lecture we will try to understand these things in more deeply.